Today we're going to be adding integers. Addition is combining two amounts. Here's some numbers that we're going to be adding that have the same sign. They're all positive. These two are positive numbers, positive 3 plus positive 5. Let's go to our number line and use the number line to add these positive integers. We could start with this first number or the second number. It doesn't matter where we start on the number line. I'm going to go ahead and start with the first number, 3. So I'm going to go to 3 on my number line, and I am going to graph it, and then I'm going to move 5 places in a positive direction, which positive is always right. 1, 2, 3, 4, 5, and I stop at 8. So 3 plus 5 is 8. Then I go over here on the side, and I have a little picture drawn. These are squares, and in class we use little chips that look very similar to this. The yellow side is positive, and the red side is negative. So to model 3 plus 5, I would place 3 positive integer chips on my desk, and then 5 more positive integer chips on my desk. And I would put the two together and count, and that's 8 integer chips, and they're all positive. Okay, here I have 2 negative integers. So I'm going to start at the first one, which is negative 8. I'll go to negative 8 on my number line, and I'll graph it. And then from negative 8, I'm going to move 3 in a negative direction. Remember, left is least, so I'm going to move to the left. 1, 2, 3, and I stop at negative 11. So negative 8 plus negative 3 is negative 11. 8 plus 3 is 11, and since these are both negatives, we will just keep the negative sign and add the two integers. Now I'm going to go over and look at my integer chips. The negative chips are red, so I have 8 negative red integer chips and 3 negative red integer chips, and when I add them together, all together, there's 11. Negative 2 plus negative 6. Again, on my number line, I'll start at negative 2, and I'll graph it, and I'll move 6 in a negative direction. Left is least, so I'm going to be moving to the left again. 1, 2, 3, 4, 5, 6. I stop at negative 8. I'll circle that, and I'm going to fill that in beside the equal sign. So negative 2 plus negative 6 equals a negative 8. Now I'm going to look at my integer chips, which we will be using in class. Negative 2, I pull out my 2 negative integer chips and 6 negative integer chips, and I put them together, and all together there's 8. Shannon needs to make 22 cupcakes in her bakery. She received an order for 34 more cupcakes. Write an expression to match and solve. Okay, if Shannon needs to make 22 cupcakes, that means she does not yet have them. That would be a negative integer. She needs those cupcakes. And then she receives an order for 34 more, so 22, negative 22, because she has not yet made them, and then negative 34, because again, these are cupcakes that have not been made yet. She needs those cupcakes. A need would represent a negative integer. Negative 22 plus negative 34 is negative 56. Okay, so the steps that we followed when adding integers that have the same sign, either 2 positives or 2 negatives, is first, we just simply added the numbers. And second, we keep the sign. The E has disappeared there. There we go. We keep the same sign. So we added the 2 numbers, 6 plus 2 is 8, and we just kept the same sign, negative in that case. Adding opposites. On this board, we're going to be adding opposites. In this case, the first scenario says I owe $8 to Dad. My friend paid me $8. So I owe $8, which is a -8, and my friend paid me 8, which would be a +8. We're going to represent these on a number line and with our integer chips. Adding opposites is also known as something else, and by the end of the board we're going to be able to fill in that blank right there. Okay, so I owe $8, that's -8. Let's start at -8 on our number line. I'm going to graph it. And then my friend gave me $8. That's a positive amount of money, so I'm going to move in a positive direction. It is positive to be right, and so we're moving to the right. And we're going to move to the right 8 places. 1, 2, 3, 4, 5, 6, 7, 8. And we stop at 0. So -8 plus 8 is 0. We have 8 negative integer chips and 8 positive integer chips. When we put a negative number and a positive number together, a negative integer chip and a positive integer chip together, they just simply cancel each other out. It's like a negative charge and a positive charge, cancels each other out. If I have $1 and I owe $1, I pay off that debt, I have 0. I owe nothing anymore. They just cancel each other out. Okay, so I'm just going to simply go through and show that that cancels out all the way across. Those all cancel out, and I end up with 0. I rode the elevator down 3 floors, and then I rode up 3 floors. So I rode down 3 floors. I'm going to graph that 3, that -3. And then I went up 3 floors. So 1, 2, 3. Here we go. And I end up at 0. So -3, plus 3 equals 0. Looking at my integer chips, I have -3 plus +3, and those just cancel out, and I still end up with 0. I scored 6 points on a game. I lost 6 points on the game. So in this scenario, I have 6 points that I scored, so that's a +6, and I'm going to graph that on my number line. And then I lost 6 points, so I'm going to move in a negative direction. Left is least, so I'm moving to the left. 1, 2, 3, 4, 5, 6, and I end up at 0. So 6 plus -6 equals 0. And again, I modeled it with the integer chips. 6 positive integer chips. When I put those together with 6 negatives, they just simply cancel each other out, and I end up with 0. -3 plus 3 is 0. 15 plus -15 is 0. And -6 plus 6 is 0. Now, they cancel each other out. Keep in mind that -3 is 3 away from 0 and +3 is 3 away from 0. They have the same absolute value. And because they have the same absolute value on opposite ends of the number line, and we're adding them, they're going to end up becoming 0 and canceling each other out. All right, adding opposites is also known as making 0. So fill in those blanks, making 0. When we add opposites, we make 0. Okay, next we're going to add integers with different signs. We'll start with -4 plus 3. The first thing I want to do is I want to take a look at a number line. I'm going to go to, I'm going to start at 3 in this scenario just to show you that I could start with either the first number or the last number. It does not matter. But I'm going to start with the number 3 and I'm going to graph it. And I'm going to move in a negative direction 1, 2, 3, 4 places. And I end up with -1. Okay, we're going to look at this in the way that the absolute value of these numbers. -4's absolute value is 4 because it's 4 away from 0. The absolute value of 3 is just 3. When I look at those numbers, I want to ask myself, which one has a greater absolute value? The -4 or the +3? Well, the negative 4 has a greater absolute value. Since it is a negative number and it has a greater absolute value, a greater distance from 0, I know that my answer will be negative. Because when I put this 3 together with this, the 3 is going to get canceled out, and there's going to be some negatives left over. Let's look at what happens when we cancel out. We're going to make 0 with our integer chips. I have negative 4, 1, 2, 3, 4. 4 negative integer chips. I have 3 positive integer chips. So here's my 1, 2, 3 positive integer chips. And when I put them together, this is what happens. I cancel out 1, 2, 3 sets of integer chips. And I only have 1 negative left over, which is what we represented on our number line also. Either way is fine with me. You can model this equation with a number line or with integer chips, whichever you like better, whichever is easier for you. Different people learn differently, so you choose. We have 5 plus negative 2. Let's go to the number line. 5 is where I'm going to graph first, and we're going to move 2 in a negative direction. 1, 2. Left is least, so we move to the left, and we end up with 3. Again, 5 has a greater absolute value because it's farther away from 0. So I know my answer is going to end up being positive, and I did get a positive 3. Let's look at it with integer chips. Positive 5 plus a negative 2. These two are going to cancel out, and I end up with positive 3. 6 plus negative 1. I'll start at 6. I'll move 1 in a negative direction, and I end up at 5. Again, the 6 has a greater absolute value, so I know my answer is going to be positive in this case. I go over to my integer chips. I have 6 positive integer chips and 1 negative integer chip. I know that the positive and negative together are going to cancel out, and that's going to leave me with 5 positives. Negative 3 plus 0. I'm going to start at negative 3, and I'm going to move 0 spaces. I end up with negative 3. And here I'm going to model it. Negative 3, I just simply draw the integer chips. Negative 2 plus 3. I'm going to start at negative 2. And I'm going to move 3 in a positive direction. 1, 2, 3. And I end up with a positive 1. Again, I look at the two numbers. Which one has a greater absolute value? The 3 does. The 3 is farther from 0. So I know that my answer will be positive because when I put these two together, as model here with the integer chips, I have 3 positives, 2 negatives. These are going to cancel out. I'm going to be left with 1 positive. Okay, so the steps that were used when we add integers with different signs. First, we represent with chips or a number line. Second, we make 0. We made 0 here with our integer chips. And third, we write what is left. And that's what we did. Positive 1 was left here, negative 3, positive 5 here, positive 3, and negative 1. Okay, on this last board, I'd like for you to push pause and try these out. Okay, let's start with negative 3 plus 7. Negative 3 plus 7 is going to give you a positive 4. 4 plus negative 1 is going to give you 3. 10 plus negative 4 is going to give you 6. Negative 3 plus negative 3, both are negatives. When we put two negatives together, we're going to get even more negativity. So negative 6. 9 plus 3, a positive plus a positive equals more positivity. So we end up with 12. Negative 6 plus negative 4 is negative 10. And adding opposites always equals 0.